In this video, I'm going to be covering the topic of stoichiometry. Now, stoichiometry is an extremely important skill for any chemist to use in the lab. The purpose of stoichiometry is to allow chemists to predict how much of a chemical will be created in a reaction or even required to start the reaction to create a certain amount of product. So for instance, we saw this reaction in a previous video when we did mole to mole conversions. We can see from this reaction, if we look at those coefficients, that we expect 1 mole of aluminum plus 3 moles of sodium bromide. We predict that if we reacted those, we'd form 3 moles of sodium atoms and 1 mole of aluminum bromide molecules. Now, in the lab, we don't measure moles directly. There's no technology that really measures 1 mole, 2 moles, 3 moles. But we do measure things like, say, grams. So, a better question for a chemist might be if we start a reaction with 150 grams of aluminum, how many grams of, say, aluminum bromide will we get out of that reaction? And that's extremely important because we might be performing this reaction for a very specific purpose. Maybe we need a certain amount of product at the very end for us to use in some application. Now, we can already relate using our previous skills an amount of moles of a chemical to an amount of grams using the molar mass of that chemical. And we can also relate the moles of one chemical to the moles of another chemical. We just talked about that from our balanced equation. But stoichiometry allows us to use both of those types of relationships to make a prediction of how much, in this case, AlBr3 would be produced. To do this, we're going to use a very specific tool just to help us organize our thoughts. And that tool is going to be our stoichiometry roadmap. Now, the way this works is we start on the left side of the roadmap with the quantity of a chemical that we know, and we work our way across the roadmap to find our ending point, the quantity of a different chemical that we're trying to find. Quick note on the key here, the boxes in this roadmap represent quantities, moles of a chemical, molecules of a chemical, liters of a chemical, grams of a chemical. These ovals, though, represent our conversion factors. Now, they're given here as equivalences, like 1 mole equals 6.02 times 10 to the 23 particles. But as we'll see, those equivalences are going to be set up as fractions in our final problem. Without diving too much more into this roadmap right here, let's look at an actual problem and see how we use this in practice. So in example 1, we're going to start by saying we have 200 grams NaOH and an excess of H2SO4, and we're going to perform the following reaction. And the question asks, how many grams of Na2SO4 should we theoretically be able to create? Now, in this problem, I call out that we have an excess of H2SO4. This will come up in our next set of videos, what this means. But essentially right now, we're going to ignore H2SO4, one of our reactants. The amount we start with is our 200 grams NaOH. That's the chemical we know the quantity we're starting with. And I know that we're ending with mass of Na2SO4. That's what I'm looking for. So if I head down to the map, I will start with the mass of NaOH, and I'm going to end on the right side of my map with Na2SO4, also as a mass in grams. My roadmap will show me that I'm going to go from left to right. I'll first multiply my NaOH by its molar mass to get to moles of NaOH. I'll then multiply by the molar ratio to get to moles of Na2SO4. And then I'll multiply back by molar mass of Na2SO4 to get back to grams. Let's see what this looks like in practice. We'll start over here with our mass of NaOH, what we know, and put it over 1. That's right here on the stoichiometry roadmap. We'll then multiply by the molar mass of NaOH to get to moles of the chemical we know, NaOH. Now, if I use my periodic table to calculate molar mass, I'd find that I have 40.00 grams NaOH for every 1 mole NaOH. I set this up so that grams NaOH will cancel, and we're left with moles right here in the roadmap. Our next step is to multiply by the molar ratio, again from our balanced equation, to get to the moles of the unknown, the chemical we're looking for. In this problem, we're looking for Na2SO4. So for my balanced equation, I can see that 2 moles NaOH is going to create 1 mole Na2SO4. That's our mole ratio. And we want to set this up so moles NaOH cancels. If we stop the problem right here, we'd be at moles Na2SO4. But before I cancel, I'm going to chain on one more conversion factor. I'll multiply by the molar mass of Na2SO4 to get to grams Na2SO4. Molar mass of Na2SO4 is on the top. I would calculate that using my periodic table. And those are the grams in every 1 mole Na2SO4. Notice that my moles NaOH cancels, my moles Na2SO4 cancels, and I'm left with grams Na2SO4, the unit that the problem asked for. I'll then multiply across numerators and multiply across denominators to get this combined fraction. And then I will divide to get 355.13. The unit is grams Na2SO4, the only unit that didn't cancel in my problem. So that problem we went through very thoroughly. Let's take a look at one more, going a little bit faster. In this second example, the question is asking for the mass of Al2SO43, and it's asking how much can be made from 1.12 times 10 to the 24th molecules of K2SO4. And here's our balanced reaction. Now in this case, we're not starting with mass, we're starting with molecules K2SO4. So in my roadmap, I'm starting with an amount of particles of molecules. My path this time will be to, again, get to grams. We're trying to get mass of Al2SO43. But my path will go through Avogadro's number to get to moles of K2SO4, our known chemical. We'll multiply by the mole ratio to get to moles of our unknown, our Al2SO43. And then we'll multiply by molar mass to get back to mass Al2SO43. Let's take a look at the setup. We'll start with our amount that we know, 1.12 times 10 to the 24th molecules K2SO4 over 1. Using our map, we're going to multiply by Avogadro's number. Molecules goes on the bottom in order to cancel, and 1 mole will go on the top. We'll then multiply by our molar ratio from our balanced chemical equation to get to moles of our unknown, 3 moles K2SO4, right from our balanced equation. And then 1 mole Al2SO43 on top. That's what we're looking for. And then we'll multiply by molar mass of Al2SO43 to get back to grams Al2SO43. As a final check, let's see that our units cancel. Molecules K2SO4 cancels. Moles K2SO4 cancels. Moles Al2SO43 cancels. And we're left with the unit we're looking for, grams Al2SO43. Multiply across numerators and denominators, and then divide, and you should get 212.20 grams of that final chemical, Al2SO43. Let's look at one more example, but I'm going to have you try setting this one up first. In the reaction below, it asks what volume of Cl2 is needed to make 35 grams NaCl. Now notice in this case, we're starting with an amount of product. That's okay though. Stoichiometry can still make a prediction. In this case, the prediction is the volume of a reactant, and we can still make that prediction. We'll set up our map the same way. We're starting with a mass of NaCl. We're going to go straight across our map and then go down to a volume of Cl2. With this setup on screen, go ahead and try to set up your dimensional analysis. Please pause the video if you'd like to set that up. Our final setup of stoichiometry will look like this. Mass of NaCl times its molar mass, times the mole ratio of the two chemicals we're dealing with, times the volume relationship, the gas relationship for that Cl2. And that corresponds to our path through the stoichiometry roadmap. Go ahead and solve the actual math equation, see what you get. Once you do that, you should get a final answer of 6.7 liters Cl2, because in this case, we are calculating a volume. Let's wrap things up with a quick summary. Stoichiometry, the process, allows chemists to predict amounts of chemicals and reactions, whether an amount of product created or an amount of reactant we would need to create our product. We always start by balancing our chemical equation every single time, and then we'll use our roadmap to plan out our calculation. The first step is to start with the amount of chemical we know on the left side of the equation and putting it over 1, no unit. We'll then convert the chemical we know into moles of that chemical. We'll then convert from moles of the chemical we start with to moles of the chemical we're looking to find. And then we'll convert from the moles of that chemical we're trying to find into its correct final unit, either particles like molecules or atoms, a mass in grams, or a volume in liters. And that is it for stoichiometry.